Welcome back. How did you do in that exercise? Let's have a look at the solution. Let's start off with stacks. I said that with stacks, they can be implemented using arrays or linked lists. In this case, both arrays and linked lists are going to work fairly well. In the end, it depends on what you prefer and what your priorities are. And by this point, you should understand the pros and cons of arrays and pros and cons of linked lists. So we don't need to go into much detail since we've talked about it before. But one major thing is that arrays allow something called cache locality, which makes them technically faster when accessing its items in memory because they're right next to each other, versus a linked list that has them scattered all over memory. And also, linked lists have extra memory associated with them because we have to hold on to those pointers. But on the other hand, they have more dynamic memory, right? And we can keep adding things to the list versus an array where you have either a static array or dynamic array that has a certain amount of memory, and as soon as it's about to reach its limit, it's going to have to double up that memory and create new space for it somewhere in memory. So you have to think about what sort of operations you're going to do and what your priorities are to decide which one you want. But they could both work. And we're going to build a stack data structure with both of these coming up. Queues, on the other hand, is a very simple answer. You would never want to build it with an array. Or if you do, well, that's not necessarily a good idea. And ideally, you want to implement them with linked lists. Why is that? Well, if you remember, arrays have indexes associated with them. So if we had Matt here, then we have Joy, then we have Samir, then we have Pavel that are in queue. If this was in an array data structure and Matt was the first in line and we need to remove Matt from the queue, well, once we remove Matt, we now need to shift the indexes over. So we have to go one by one and say, all right, Joy is now here at index of 0, Samir is at index of 1, and Pavel is at index of 2, and there's nothing at index of 3. We just unshifted those arrays. It's an O of n operation, a linear time. Versus something like a linked list, where all we have is a pointer to the head, and then perhaps we have a pointer to the tail. And all we need to do is say, head, well, is Matt. We want to remove Matt, and Joy is going to be the head, and nothing else changes. And that's an O of 1 operation, or constant time. I hope you are able to get the answer. Otherwise, at least now you know, and this is a very common interview question that you might get asked, that hopefully you have an answer to now. But enough talking. I think it's time for us to build these data structures from the ground up. I'll see you in the next video. Bye-bye.